Ladies and gentlemen, welcome to the Two Doors podcast. Today, I have the pleasure of introducing Aaron Sempf, a true innovator and problem solver in the world of technology. Aaron describes his work in one sentence: I solve complex problems with technology. With over 20 years of experience in distributed and embedded systems, what we now call cloud, hybrid, and IoT. As a neurodivergent professional with ASD and ADHD, Aaron has transformed his unique perspective into a superpower, leveraging hyper-focus and adaptability to thrive across diverse technology domains. In his current role at as a next-gen tech lead for AWS Partner Org in Asia, Pacific, and Japan, Aaron serves as a forward-looking CTO for the region, always focusing on what's coming next. Passionate about the future, he's committed to shaping it, because as he puts it, I'm going to spend the rest of my life there. Let's dive in with Aaron Sempf. Welcome to the show, Aaron.
Thank you very much.
How does that make you feel when you hear that?
A little self-conscious. I guess one of the downsides of ASD or ADHD both is you're hyper, aware. And so I'm always self-analyzing, self-assessing, and when I hear things, I wrote that. So when I hear somebody else say it, it's a little bit confronting.
Hey, it's impressive. I love how you've turned that into a strength of yours and hyper-focus. And I'm excited for today because I've always respected you've known you for many, many years, and just seeing your progress and growth. And you've just come back from being overseas as well, haven't you? And so maybe you can tell us a bit about what you've been up to at AWS and some cool stuff that's going on.
So non-stop travel for the last 4 months approximately. As you're aware, Gen AI is pretty much the hot topic at the moment for the last 2 years, I think. So a lot of my second half of this year has just been focused on helping our partners and customers develop what we call Gen AI practices, but from my perspective on software engineering, so helping our partners develop software engineering practices around generative AI and using generative AI, not just developing generative AI products like ChatGPT or, like the products that most people are familiar with, but actually using generative AI in their own practices to help optimize what they do in terms of platforms and application engineering. So it's been almost a whirlwind tour of APJ for the last 4 months, like skipping across countries at both CXO level. So having like the CXO discussions around how to optimize their business, why would they adopt these types of tools and practices, and then getting hands-on with the line of business people, teaching them how to use tools like Q Developer and utilizing generative AI in their actual software engineering practices, but not just for code gen. Like most sales people are focused on selling the output of the tool. Like, hey, this generates code, then you can use it to generate code. Me coming from the software engineering background, helping them to understand how it fits across their entire software development lifecycle. And so working with people to understand, you're not just writing code 100% of the time. As a developer, I think Gartner tells us the average person develops like 1 hour of code a week or a day, 1 hour of code a day. And the rest of the time is spent on, like understanding, not writing the code, but like what's next, what to build and that's kind of my focus is, as you said, I'm the forward-looking CTO. So I'm looking at what's coming next. So it's about how do we use these tools to solve the problems that you don't know you have yet. And those problems that I'm estimating, as well as I work with Gartner, I work with a couple of different of our analyst partners to understand what's coming next, is the complexity, the shifting complexity with generative AI means that the average everyday programmer now has to be a lot more aware of what to build, not how to build it. So the Gen AI can do it for you in terms of the how to build, but knowing what, that's the tough question. So it's just been 3 or 4 months of talking, not just teaching, but talking, like understanding from our partners, what are you building? How can we help you? What are some of the hurdles that you're facing? And that, to me, that's my bread and butter, is is helping people solve their problems with technology. Yeah, I wrote it, but like that's it, right? Like if a partner comes to me and says, "Oh, we're struggling with being able to deploy fast enough, or being able to understand how to break our people into different teams so that they operate in more of a platform versus application engineering point of view," it's everything. It's not just technology, but it's people practice supported by technology. So I solve problems with technology, but it's how do people interact with technology? What are the practices around that technology? And so I have so many insights. My 2025 is basically packed out with what I'm going to be doing to help solve these problems.
Wow. I'm very curious about what some of the problems are that you'd be solving, because I remember where you showed me a few years ago some of the actual pieces of work you'd written about AI way before this all came mainstream. And I love it. This is a new world record, I think, for the podcast that we got straight into AI. It's like, but yeah, what are some of the new problems that you see coming out? And yeah, tell us a bit more about that.
So AI has always been, I'm not a specialist in AI, but it's always been something, as a distributed and embedded systems engineer, AI has always played a part. And one of those parts is, from the systems point of view, is understanding where it fits and how to run it. In embedded systems, obviously, like when I talk about embedded systems, your smartphone, that's an embedded system. So understanding how much memory, how much space you have to actually work with on a smaller platform like your mobile phone, and then understanding with the current trend with LLMs. So generative AI has introduced, since it's not just come out in this last few years, as I think we talked a few years back before ChatGPT became apparent. I was talking to you about context back in those days, developing the AWS chatbot that's on the AWS website. That was one of my little babies. And one of the problems that we were trying to solve there was extended context. Because it's easy to have some. So there's two different types of AI. There's symbolic AI and there's neuro AI. So symbolic AI is more the traditional form where we set all the rules in place, and then neuro AI is more neural network. So it's deep learning. It's been most people understand deep learning as AI. So back in those days when we started developing it, it was a symbolic AI. So there's a whole series of rules around what it has to meet based on conditions. So as you're talking, it's looking for, it's using natural language processing, but it's looking for specific keys, and then it's applying specific rules. With extended context, obviously, I'm sure not everyone listening has read the paper on extended context, which was released in 2017, but that's the kind of things that we were looking at back then, and understanding, like how do we bring all of the capabilities that we have now in generative AI into a smaller embedded system that applies more symbolic AI. So it's very rules driven, but it has the extended context of LLMs. I can all but guarantee that over the next year, you will see the key players in AI will start to look at the combination of neuro and symbolic AI together. So it'll be like neurosymbolic or symbolic neuro. Probably neurosymbolic is probably the best way to explain it. But utilizing both the extended context, the way that we do deep learning, with the pre-constructed rules engines around symbolic AI. So a lot of the forward-looking problems that I'll be looking to solve are another sort of key trend that we've seen with generative AI over this year specifically is organizations moving towards an agentic AI architecture. So agentic architecture is not new. Like, we've been doing agentic architecture in event-driven systems for a very long time. However, now those agents are supported by generative AI. They don't need to have as much predefined instruction. So a generative AI LLM that understands a specific domain. So if we talk about a generic LLM that's trained like one of Anthropic models, which is trained for a business context, but then applying retrieval augmented generation, so RAG, which is a very specific subset or a very specific domain that it uses to derive specialist knowledge. If we can think of a very simple execution agent that says, all right, well, I'll hand my request off to the LLM and it'll tell me what to do, and then having things like being able to go and do a search or go and update a record or go and take some action, some sort of calculation on the output of what the LLM or the generative AI has provided. As an example, it could be something as simple as like a booking agent. I need to go on a holiday. I don't want to organize it all. Usually, traditionally, we'd call the agent and say, hey, I'm going to Chile. Like I've never been there before, so I don't know accommodation. Please organize my flights. I need to hire a car. Is a car a good idea, or should I get a scooter? Or I don't know. You organize it for me. Here's my credit card details. Go and do it. That's the traditional way of talking to a person. A lot of that offloaded into an agentic architecture is now specifically an agentic AI architecture. Is you talk to the orchestrator, so that's the person on the end of the call saying, here you go, these are all the details. I want to go on these dates. I want to fly to this destination. I want to hire a car and I need some accommodation while I'm there. We'll stay in the one place so we're not traveling around, so it's just the one hotel or resort or whatever, while we're there. But then that agent talks to other agents and it says, all right, you're the flight booking agent. So from this date to this date, I need a flight in and a return. You're the hotel booking agent. So I'm going to book a hotel at this destination for these many nights. And then we want a non-smoking, king bed, whatever the preferences are. You're the payment agent. So based on these two responses from those two agents, go and make the payment to those two payment gateways for the hotel and the flights, and and I missed one, the car booking agent, whatever. So it's an agent orchestrating the workflow. That's a common practice now. Like that's a common practice in event-driven systems.
Yep.
It's been augmented by using generative AI, so it's a lot more generative AI driven and a lot less having to write the business logic to handle everything. All the business logic needs to do is handle the interaction between the different systems. So it's more integration logic. Where we're going, where some of the problems that we're facing now is specifically from distributed and embedded systems is the models are too large. So some of these large language models are too large, and they're too broad. And to be able to perform specific tasks, we need them to have that broad contextual knowledge of, what to do, how to do, or, the thinking that it does. It's not really thinking. It's looking at vectors and how close they are to each other based on the context of what you've asked it. So that's the vectorization of LLMs. But the key in it is we need to be able to create smaller models with the same amount of sort of contextual knowledge for a specific domain, but then we want to integrate those in a way that isn't orchestrated. So we don't want to have one agent saying, hey, agent number 2, you go and do this and give me your response. Agent number 3, you go and do this and give me your response. We want to move towards more of a event-driven pattern, which is more of a broker situation, where now you can have a broker who says, all right, I'm aware of 5 or 6 different agents that I have access to. Based on the incoming request, I'm going to say, all right, agent 2, 3, and 4, I need you to go and do something. And when you're ready, just send your response over there. Instead of send it back to me, send it to over there. There'll be another agent which will collate it all and put together a notification and say, your entire holiday has been created. Here you go. Off you go. You just show up to the airport and you're good to go. So that's more, if we think of traditional integration systems, that's a message brokering system. But we want to get to the point where it's now an AI-driven message brokering system where the agent isn't in control of the other agents. It's just brokering messages to the other agents. And then the other agents pick it up. They can have 1,000 messages coming at them and then just handle it in their own time. So one of the problems with this is one of the problems we're trying to solve. So one of the problems with the agent orchestrated workflows is that it can only handle one interaction at a time. Or if you've got multiple instances of that series of agents, then you've got a scale of everything. So now you've got multiple orchestrating agents, multiple of each, and so you're actually consuming a lot of energy. You're paying a lot in usage. Like the costs and the resources are exponentially getting larger. We don't want that. Like embedded and distributed systems is about making the most of the resources that you have at hand without having to scale them out exponentially. So we want to be able to scale for resilience. We want to be able to scale for security. We don't want to have to scale just to perform. So the problem that we're solving now is, one, through resilience. I can say, through this message broking orchestration, I can say, bang, here you go. here's a message that goes to agent number 2, and agent number 2 will pick it up. But then you've got another 1,000 that are coming at it straight away. So we work with existing architectural patterns around event and message brokering. So you can have a queue, and it can just pick it up and work timely from that queue. Or you might have multiple instances based on if you've got 1 million messages, but instead of exponentially expanding to 1 million agents, you've just got 2 or 3 handling 1 million messages all coming in. So it's in a timely manner. But then it will hand its response back. It doesn't have to go back to the orchestrating agent. It will hand its response back where it's instructed to send it. And so then from there, we have a much more efficient, a much more malleable. I can start adding agents to the system without having to change logic or change configuration. The only thing that needs to know about it is the brokering agent. And so there's a lot in that. I've sort of covered it at a high level, but there's a lot of considerations in that.
Yeah.
And businesses are only starting to scratch the surface at the moment as to where are the areas that we should augment. So where should we be using generative AI? Not all agents have to be AI driven. As I said, we've been doing agentic architecture for like decades. As long as I've been in the industry, I've been doing event-driven systems, and a lot of it is agent-driven. By agents, I mean you've got services running on a network that pick up a message, do some processing, and send it somewhere or hand it back or whatever. That's an agent. So an agentic AI architecture is now just taking those agents, augmenting them with generative AI or other forms of AI, and allowing them to work in a seamless manner that solves much larger problems. Because now we're talking about the architecture, but what are the problems that we're trying to solve? So that's my job. Is not like, first of all, yes, help you solve the scalability, the resiliency of it all, but why? The key question to anything is always why. What are we solving? What are we trying to build? What problem is the business trying to solve? And so that's the important part for me, is when I go to AWS partners and customers, when they say, oh, we need agentic AI, I'll be like, why? What problem are you trying to solve? And then when we get into the nuts and bolts of the why, it's like, great, you know what? I've got an entire solution for you that doesn't require generative AI, and it's going to be a lot more efficient, but then we'll use generative AI to augment where it makes sense.
That's fascinating. That's fantastic, Aaron. And it gets me excited.
Yeah.
And for anyone that's listening, could you maybe, that they've never heard of generative AI, like explain it to a 10-year-old, like what's the definition? And the second question I've got there is, are you going to coin that term where you were like, there's two different types of AI?
Oh no, that's I'm not inventing these terms. These are
you could do it right now.
Okay, I'm going to coin the term NeuroSymbolic AI.
NeuroSymbolic AI. You heard it here first. Yes.
So I guess you can coin the term NeuroSymbolic AI. Neuro AI. So that's artificial neural networks. So neural AI and symbolic AI are the two sort of cornerstones of AI ML. We've traditionally. I think symbolic AI was around long before neuro AI or neural AI. Neural AI, I think, became more popular because of its ability to train deep data sets. So the difference being neural AI requires a deep amount of training, and it's called deep learning because there's layers of neural networks, and it requires a big amount of training data. Symbolic AI, like it's in its name, like it's symbolic of, right? So it's rule sets. It's very highly complex rule sets. Do you remember what was the IBM Deep Blue?
No.
So Deep Blue beat Gary Kasparov, the world chess champion. It was the first AI to ever beat a chess. So that was a symbolic AI. So that was an AI built on. I'm going to take a guess, but I'd say thousands of specific rule pathways, like where it could potentially go, and it's just done in a way that it seems real. It seems like a person. Like, this is why we call it artificial intelligence. But at the end of the day, it's just many thousands of pathways of potential possibilities that it chooses. This is the most efficient or most effective move. So that I remember that one because I love chess. So I remember when Gary Kasparov was beat. This is going back when I was a kid. So, but then that kind of took it didn't go anywhere much further than it's capabilities at the time, and that's when neural AI started to take over because of the ability to train large data sets. And the rules that neural AI work from are actually the network itself. So they can apply, like they derive what to do based on the network and based on the data that it's trained on. So you can use the same neural network, but train it on different data sets and you'll get a different response. For a symbolic AI, it's all trained according to the rules. You're going to get the same outcome, based on given the same inputs. So, you were saying you were asking me to explain generative AI.
Yeah.
So thinking of what I just said about neural networks, neural AI. Generative AI is the ability so first of all, it's a deep learning ML, right? So it's got those many layers of training data. So it's trained on, let's just say, human knowledge, right? It's trained on a lot of data. And then from that, its capability comes from being able to generate. So this is why it's called generative AI. It generates a response based on the context of its input. So you ask it a question, like, mirror, mirror on the wall, who is the fairest one of all, right? If you ask it that context, if it's been trained on nursery rhymes and all of human history's storytelling and whatnot, it'll probably come back with a response that is somewhat similar to what's in the book, right? Because it'll see that every time. So when I say see, right, what I mean by see is it's all math. So everything, human knowledge has been vectorized, and by a vector I mean every single word has a weight. And that weight, depending on what word comes next or what words in combination is with, are given a weight. So this is what we call tokens. So you have like 1 word, 2 words, 3 words, and then you have a sentence, and a sentence is a paragraph. And depending on how much context you're using, it'll use those multiple words, sentence, multiple sentence, paragraph, multiple paragraphs to derive a vector between next word, next sentence, next paragraph. So this is where it is generating a response based on mathematically what is the closest vector, what is the closest token to what you're asking. But it derives context. It derives that context through natural language processing. So it first looks at, what are you asking? And then it breaks it down into, this is the key or the core of what's being asked. A lot of generative AI applications, so people who have applied this in different applications, they have what we call pre-context or systems context. So they apply a lot of pre-prompting, saying you are a publishing agent and you only are interested in what readers will be interested in. I don't care. You don't care about if the person asking a prompt has pets or mentions that they're going to take a break over the holiday. You only care about what they're currently reading and what you can sell them to read next. That's like a pre-prompt. And so you start having a conversation. You go, oh, I'm taking my cats on holiday to blah, blah, blah. And then it might come back and say, oh, that's great that you're going on holiday. What book are you reading? So it now has a context that it's been instructed to follow. And based on that context, it will look at, well, what is most relevant in terms of that vectorization. So it's not smart. It's not thinking. It's not a thinking machine yet. We're not at artificial general intelligence, but we're at a point where we can apply a context and say, well, this is the most likely context to relate. And that's all the math. So that's where crazy people like me who love math get involved and build the algorithms and work out how to bring it all together. And that's where I can apply from my background in understanding that there are limits to generative AI, or there are limits to what we're doing with neural AI, just like there are limits with symbolic AI. And then looking at, as a futurist, as a technologist who looks at the next step in a practical way. I'm not like a science fiction writer. Like I'm looking at things practically, where things are going. I can see, well, to be able to break certain boundaries, and this is a prediction, obviously I can't tell the future, but to be able to break certain boundaries, unless there are some major advancements that I'm unaware of in neural networking and in generative AI, and or for symbolic AI for that matter, then there's going to be a point where we're going to have to apply the two together to overcome each of their boundaries. And it's like, if you consider looking at experience, if you consider the last 2 years, the last year's worth of business applications, so our customers and partners who have come out with their own applications of generative AI, how they're applying them and how they're making them more efficient is it's not actually one LLM. They're not just saying, here is my input and give me my output. A lot of them are multi-model, that's very difficult to say, multi-model, where they'll validate against each other. So they'll ask an input question. The first model will generate an answer and hand it to a second model, and then the second model will have a pre-prompt that's saying, is this valid, or is this correct, or can you improve on this answer? With your given experience in this domain, how would you improve on this answer? And then it's given a response that is more close to a very accurate answer. Now, going back to understanding that generative AI is generating a response based on vectors, I'm sure people have heard the term hallucinating. So I'll say this, you'll only hear it from me because people don't want you to know this, but the response from a generative AI is 100% hallucination. It just so happens that it's about 99% accurate most of the time. So people think, oh, this is great, it's smart. It's not. It's 100% hallucination. It's 100% generating a response based on the vectors, based on the math that says this is the most likely, next word or next sentence or next paragraph to come based on what I've been asked, based on the context of the question. So it's 100% generated, 100% hallucinated. But based on the question and understanding the context, this is the whole point of generative AI. It's an extended context. So it's not just looking at words or a sentence, it's looking at the entire context of the paragraph or the prompt, or even if you've given it some pre-prompt knowledge, it's looking at the entire context and building up a response based on all of that. Like to get a further understanding of how that works, we got to get into the math. So I'm not going to do that, but it's somewhat accurate, 98, 99% accurate most of the time. Sometimes it's completely not accurate at all. But then to make it even more accurate, that's when you hand it over to another model and say, right, this is my response. You have some additional insight based on your RAG or based on your tuning. How can you improve on this answer? And so a lot of the successful products that I've seen are taking that multi-model approach. Even our brains, the way that our brains work, it's not one LLM. Like if you consider the neocortex, which us mammals have that other species don't have, that's doing a whole extra level of processing that, say, our lizard brain, all of our subconscious, our our fight or flight response, even just our basic instincts, hunger, all of these things, they're not managed by our neocortex. This is all subfunctions, all different parts of our brains, or different. If you want to derive the context from LLMs, then you could say you've got multiple different types of AI. Well, it's real intelligence, but different types of processes, models, all running inside your brain. Even in our neocortex, we have multiple hemispheres which are doing different things. When you have deja vu, it's not a matter of this has happened before. It's a matter of one hemisphere is trying to catch up with the other. So one hemisphere sees it a split second before the second hemisphere sees it, and it goes, oh, I've seen this before. That's just the recognition that your hemispheres are catching up with each other. So there's a whole level of science, neuroscience, that we can start to apply to neural networks and symbolic AI, and like bring the two together to understand how can we build a model of the human brain from our understanding of current technology. And I still think we're 5 to 10 years away from achieving something similar to human brain type, artificial general intelligence. But we will continue to augment on top of, and which is what we've done with generative AI, augment on top of what we built and continue to build processes out. But at the same time, bringing it back to what I do, we have to continuously make sure that we make it small enough to fit on our systems, make it small enough to run on the resources that we have. Otherwise, it's going to cost us however many resources to run one process, which is going to bankrupt the world's, coal reserves, or, depending on how big we get, right? So there's a fine line between capability and usability. And so I fit right between that line of capability and usability.
Well, thanks for sharing. I'm thoroughly enjoying this conversation, Aaron. And I think I've got so many questions, but we might have to do a stage 2, because I'd love to get into more of the security around where we're going, and because that's also a hot topic, and integration and everything like that. But switching gears, I'd love to talk about your career. Like, if you could go back to your younger self, what advice would you give them?
What advice would I give my younger self? What advice would I give other people who are younger, or would I give my younger self?
Both.
So I think my younger self, when I was younger, I was very unsure of myself because I knew that I had problems. I have learning disability in certain area in terms of I find it difficult at time to concentrate, especially in a school setting where there's a teacher at the front talking and you're sitting at a desk. I was the kid up the back, talking and messing up. And my report card during all of primary school and the first half of high school was Aaron would be a much better student if he just didn't talk, or if he paid attention. But it wasn't that I was a bad student, and it wasn't that I didn't have the aptitude to learn. It was just the wrong environment for me. In my senior years at high school, I took learning into my hands in that my the deputy principal at my school helped me because I did really well in certain areas. The deputy principal wrote to the school board to me to get permission for me to go to TAFE. So during the last 3 years at high school, I was doing my diploma in IT at TAFE at the same time because it was hands-on. And that's how I learn. I learn hands-on. I have to build something. I have to do something to learn. Yes, there's a fair amount of reading and having to listen or whatnot. But if I can break that reading and listening down into small chunks, then I'm able to digest it much easier. So I won't spend an hour in a lecture. At university, I spent an hour in a lecture and I fell asleep and I got flunked for that class. That was my discrete mathematics class. But I love math, right? It's a subject that I really love, but I just struggle to maintain concentration. But when I can take a lecture and I can do it at 1.5 speed or 2 speed, depending on how slow the lecturer talks, and then break it up into 15-minute increments, then I can listen to it for 15 minutes, go off and do something else, come back, listen to it for another 15 minutes. So my entire career now is, for some people, it may be too chaotic, but my entire career is now broken up into small increments of doing different things throughout the day. I don't time block and say, for the next 4 hours, I'm going to do this. Unless, so this is where the ADHD versus the ASD come in. Under one of my competing conditions with ASD is my hyperfocus. So I can get to a point where I'm fixated on something, almost to obsessive compulsive, right? I get fixated to the point where somebody can come up and tap me on the shoulder and I won't even know they've tapped me on the shoulder. I'm just so fixated, but it's got to be on a complex problem. Like if I'm coding a solution to something and I'm trying to solve something, my brain gets so involved in it that it's just focused. I can't apply that same level of focus to reading or learning like a textbook or listening to a lecture, right? So to my younger self, I would have said understand and embrace what other people call disabilities. I've learned to understand them as superpowers. Knowing where to apply them is the important part. Don't, just because you're neurodivergent, whether you're ASD, ADHD, there's so many different conditions on the spectrum. Asperger's, you'll find in technology, there is many people on the spectrum. Not all of them have learned to embrace their disabilities. I hate calling them disabilities. It's only called a disability because it's not the norm, right? It's not neurotypical, it's neurodivergent. But it's only neurodivergent because I think of our history, of our culture, of, wanting to propagate specific behaviors. We all work in factories for the Industrial Revolution, so that's the mindset that you want. We don't work in that environment anymore, so all of these neurodivergent mindsets are actually starting to flourish in IT and science and different areas where it requires people to think outside of the norm or to think abstractly. Yeah. My brain doesn't work in a fixed pattern of, I must, follow this bouncing ball to get to the end. It'll be like, but what if I jump to the end first and see what happens there? And if that doesn't work, then pivot and go halfway. Or, it's almost like a sorting algorithm where you start halfway, and then if it's less or more, then you jump to the next halfway mark. I can't follow the bouncing ball step by step by step. But knowing that and embracing that and learning where to apply it. So you've got to be self-critical as well. But have confidence. So I wasn't confident. Coming out of high school, I was academic. I had an aptitude for learning, but I wasn't confident. I had self-doubt. I analyzed everything that I did. And it took me time. It took me going through the army. It took me, different environments, different type of working conditions to actually learn, what? The person doesn't matter. Like, you are you. Everyone is them, and everyone has their own hang-ups and disabilities or, superpowers or whatnot. Just focus on what works for you.
The brain is learning itself, right? It's like, thanks for sharing as well, because I totally respect that. And some of it resonates with me as well, Aaron, that I think you've got to know who you are, but also how you learn. We're all individual. And
Absolutely.
Even pre the industrial era, we had the agrarian society where everyone was quite entrepreneurial, would trade some shells, and that's how currency was. And it's like, well, we were divergent back then. So I think, we should change the name to something different. Because I think if you can understand yourself firstly, and you can understand how you learn and then how you perform, as well as having ability to relax and recharge, because that's another thing, right? When you're a higher achiever, you can go to the burnout stage and you don't even realize, because you're thoroughly enjoying solving a problem.
I have burned out maybe 3 times in my career, not to the point where I've had to leave, my employer or anything like that, but it's got to the point where I've not hospitalized, but to the point where, you got to just, actually I did have to go to hospital once just for, because I was too dehydrated. But it was just an IV, so it was just go to the emergency, they hook you up to an IV, observe you for 24 hours, and once you're hydrated, they let you go. But like understanding that, knowing that you can burn yourself out. I'm also, I've had to learn to be extroverted. I'm naturally an introverted person, so I can recharge on my own. If I can do nothing, I can read a book, or I enjoy reading in short stints, or I'll watch. I like anime because it's short episodes. I can watch a few episodes, go off and do something else, or watch an episode, do something else, come back and watch another episode. To me, that's recharging. As long as I'm not talking to people, as long as I'm not performing or interacting, because even in the work environment, I expend a lot more energy than what I would in my own personal environment. Like, working from home has been a great help to me, because in the work environment, one person, I think it was on LinkedIn or somebody, once posted, be the employee that you want to work with.
Yeah.
And I said, well, that sounds good in theory, but doesn't work for me, because I want to work with somebody who's more like me, who, when we talk, it's just an exchange of information. There's no emotion in what I say. I want to be able to interact in a way that if you differ in your opinion, if you think you've got a better understanding of what we need to achieve, don't be backwards in coming forwards. Just say, no, it's not going to work. Do it this way. And then give me the data why, and have that information exchange. If I do that in this work environment, and I have done it in the past, and I've been reprimanded by HR, by my managers, like, you can't be so abrupt, you can't be so forceful. And I'm like, forceful? When was I ever forceful? I'm just saying it won't work because of these reasons. But the approach, the softening, the emotion, everything that has to be put into communication, that's just communication. Like doing what I do in a public forum, I have to be, like, my perception of me is different to the me when I'm, in a room by myself or with my family, or that me is it takes double the amount of energy, because it's not a performance, it's not a mask, but it's making sure that I'm being the, let's say, norm, so I'm treating people with the respect that they expect, because that's how they want to be communicated with.
Yeah.
But if it were to be the person that I want to work with, no, it'd be sharp and abrupt, and here's the information, and if you differ, give me the information that differs, and we'll go off and do this, and I'll go and action something without having to talk to you about it. But if you disagree with it, come and take over and change it. Like, I don't take offense to that.
Yeah.
I don't take offense to people coming in and saying you're wrong. I won't say, you can't say that. I'll say, show me why.
I call it, we're in the emotional era, because it's very heightened. We're not going off to war anymore. It's very much like, hey, let's listen to our emotions. And I feel for the next generation coming in, because it's even more, but we do have to have those people skills. And I'm very similar to yourself of my energy levels. I'm an ambivert. Have you ever heard of that?
No.
So there's, obviously, you've heard extrovert, introvert. Ambivert is where I actually get energy off of other high energy people, where it's like a great conversation, you come away and you're tinkering in your mind because you're like thinking so many great ideas, rather than being around energy vampires and you're just like, whoa, what happened there?
Yep.
And you just feel it. So I'm similar, where I have to recharge. And over the years, I've had to build some self-soothing practices, know what I enjoy most, what recharges me. And I think life's a marathon, isn't it? But in a marathon, you have short sprints and then you can rest and recharge.
I like that ambivert. I'm going to remember that. I would say that I'm similar in a way, but I do need that personal time to recharge. And that's where I've gone off into a room by myself. Like even here at work, I'll lock myself in a focus room and just listen to some music. Music has been my throughout every single situation of my life. Music has always been there. Like that. Yeah. That's how my brain works.
Yeah,
I put on music. It is both I don't know. It's a, what would you call it? Like the metronome. It sets my tempo, but I can also affect my tempo. So if I need energy, I can use different music to give me energy. But if I need to just chill, I'll use music to help me chill, and then I can get back out into the world and keep going. But I wanted to say one thing. You mentioned we're not going to war. Now, I have a good insight from being in the army. And being in the corporate world, especially corporate IT in a large organization like AWS, we're all about high functioning teams, like super powered teams. One of the things that I appreciated from the army and was similar to how I like to operate, and I think I've learned it from my personal experience, but also having to operate in an environment like that, is that the high performing teams, the most high performant teams, do communicate in a way where it's just information exchange, and there's no exchange of emotion in the communication because of that trust they have in each other. So they have a utmost trust that they're going to get their job done because everyone around them is supporting them in doing their job, which all collaborate together. So they're not worried about, oh, if I'm not doing this, are they going to do their job properly? Or, a bit of backstabbing here, bit of undercutting there. Nobody's worried about that. They're just thinking, I've got my job to do. I'm going to perform my task. And so if I need to relay information, it's just information. There's there's an undertone here because I might think that you might take my idea and run away with it, or it's none of that. And we have teams like that here in AWS, which is the teams that I love working with the most, is because they're not thinking, oh, you've got a good idea, I'm going to use that for my next promotion, or I'm going to use that for my, I'm going to get a patent and start a new service and get all the credit for it. Nobody thinks like that. It's all about, hey, I've got a job to do, I'm going to achieve my job, and I want to work with you because we're doing fun stuff. And then the most performing teams are the ones that just focus on getting the job done, and they're not worried about the emotion and So that's where I have the most amount of fun.
And you hit on a great point, which is trust. And I think that like a principle I use is trust then verify. Because like there can be so much mistrust out there. Like everyone's like wrong until proven right. Like someone knocks on your door now, it's like down, who's at the door? Like 20 years ago, it'd be like someone knocks at the door, be like, who's at the door? Oh my God, get like the best food out, and how can we invite people in? It's a different world. And I think that comes from knowing your why, knowing your North Star, what's the team trying to achieve. And you hit on some great points there, Aaron. And yeah, in winding down as well, like I'd love to know some wisdom that we can share with some of the audience that, you've obviously, you're doing some great stuff, and I'd love to hear more about some of the projects, because I know last time we spoke, you were saying you're doing some really cool stuff. But yeah, if you want to talk to maybe some of them or junior software engineers out there or people who are a bit lost, like what would you advise to them?
My advice comes from two separate angles. There are two separate types of junior developer at the moment. There's the junior developer that's come through education. So they've gone and studied computer science or some relative field. Then there's the junior developer who has come through, maybe done like an arts degree, or maybe even just come straight out of school and done a short course in coding, and they just pick up coding really quickly. Unfortunately, it's going to become harder for just the general coding capability as AI starts to take over the easier forms like web development and the simple side of applications development. My advice is go and learn your patterns and practices. So it's not so much about what to code or what language to code in, but understanding the patterns and practices, like the Gang of Four patterns. Gang of Four is a series of application patterns that were created in the 90s, I think. I can't remember the exact era, but by 4 computer scientists who wrote or who documented the topmost patterns that all applications use, and they set them out in a way that is, these are the patterns and how they flow without an understanding of the language that they're used, or so you can apply them to any language. It's just patterns. Then there's event-driven patterns. Then there's, depending on what you're getting into, go and learn the patterns of your profession. So forget about the languages, because you'll learn Python, JavaScript, Java, C#, whatever. Next year, we've spent some time at AWS integrating Rust, which was only released a few years ago, right? So new languages are coming, old languages die off. The language isn't the most important part. It's the paradigm. So object-oriented programming, functional programming, aspect-driven programming, but understand the patterns. And as a junior developer, if you start getting into using tools like QDeveloper to help you with augmenting your practices, then you don't have to start saying, write me a block of code to do this. You start saying, write me the commander pattern to handle an input of this structure and an output of that structure. And so you're becoming an orchestrator of the code instead of having to write the code. You'll gain, I think, experience much faster as your output becomes more improved, because you understand the patterns. And then when you can understand what patterns to apply, you'll climb the chain or climb the scale a lot faster, because when people give you a task, you'll be able to read through what the business objective is and go, oh, I know what pattern to apply. And it'll be very simple, as opposed to going through and learning the specific syntax for the specific language, and without assistance, having to go through and code it all will take you a lot longer. And you might go through some trial and error, having not known the patterns on what's the right way, because I've seen junior developers without any pattern-based understanding come through and just start coding stuff based on, this is an assignment I did at uni, so I can apply this first, and then it doesn't quite work, so you start amending it. Then you start looking at Stack Overflow and how does somebody else say to improve, and then you've spent 3 or 4 days on one task, which for a senior might have taken a couple of hours. But it's only not because they're better at coding, but because they understand the patterns.
That's wisdom.
Yeah.
And we had Raul on the program last week, and he was saying similar, but he said fundamentals.
Yeah.
And so I love that, because it's
patterns are fundamentals.
Yes. And is there a specific book that you would recommend with those 4 computer scientists that they gathered together? Is there something people can read?
Google search on Gang of 4 Patterns. There's their original book that was published in the 90s, but there's been many books since then on discussion of specific patterns in the Gang of 4 Patterns. If you're a systems engineer, more like myself, and you want to get into distributed and embedded systems, look at more EDA, so event-driven patterns, and then read things like domain-driven design. And there's so many texts by so many different people discussing the original author of domain-driven design, to discussing implementation of domain-driven design, then discussing implementation of event-driven patterns. There's so much. The same for data patterns, integration patterns. It's all relative to the field that you're in. So pick up, if you're on a project, and understand that you're only writing business logic, then start with the Gang of 4 Patterns. If you're on a integration project, then start with event-driven patterns, and understand the difference between orchestration and choreography, or pub sub versus streaming, or there's so many different patterns. They're the fundamentals when it comes to engineering. Then where you apply your engineering could be from configuration through to coding. There's so many different ways a developer can implement. It's not all just about code.
And I think in addition to that is that what I'm seeing in the market is a lot of people are looking for those people skills. On top of that, not only does a product engineer is thinking for the product, but hey, with my people skills, I'm going to talk to the user, understand what the user's doing, and be able to collaborate, and like us building some more of the emotional skills around that. But who you can talk direct to, and then who you have to build that more relation.
I think you're pretty safe as a junior developer. If you're looking specifically SDE, like software development engineer, you're pretty safe to be in a dark room with your headphones on, in front of a laptop just coding. You don't need those people skills straight off. it does for advancement. As you become more senior, obviously you start with interacting with your team. You might want to become like one of the lead developers, and then you're actually leading a subgroup of your team or your organization. So now it's important about the intercommunication between teams, as well as coordinating the communication and the tasks within your team. From there, SDM, you might be an SDM for a single, product, or you might be an SDM that sits across multiple teams. The SDM and the lead software developer are generally the ones where I would say that's when you should be getting in front of the customer or getting in front of the partner and actually having the conversation around UX and UI. So it's now the usability, not just the functional output, but because as a developer, you might go, oh yeah, here's the functional output that the business requirement asked for, but the user's going like, but I can't use it. Like it's functionally what we asked for, but it can't be used. That's where the lead and the SDM make the most sense. And that's where, other roles start to blend in, like the product owner and the BD. And, depending on the type of organization you exist in, as a junior dev, you're safe. You can be an introvert like myself, or, you can have lacking people skills like myself. And then as you become more senior, it's not about your ability to code faster or, more complex. It's about knowing who to talk to and how to talk to them. And because I'm very abrupt. I'm a very difficult person to talk with if I'm just my natural self. But understanding that and overanalyzing myself, I'll want to know the person that I'm going to talk to, and I'll approach them in the way that they expect, not in the way that I expect. So for some people, it's different. I talk with different people around AWS in different ways because that's what makes them comfortable. When you get to, so my job family is what we call a solutions architect. Now, there are junior solutions architect roles, like an associate solutions architect, but the role is very different. It's much more of a learning role, which is the same as if you're an SDE or the same as a SysD. So we have systems development engineers. At the junior level, you're all learning. You're learning to do your job. As an SDE and SysDE, you're applying that learning a little bit more than, say, an associate SA or somebody in a junior technical role. But throughout all of those technical roles, those soft skills, the more senior you become more and more important. My job now is 90% soft skills and 10% writing code, or 10% drawing a diagram to represent something that somebody's trying to tell me to understand, like doing a whiteboarding session, or whatever it is, to graphically represent a problem and then create a solution for it. That's why the job family is called solutions architect, because the whole point is to solve problems. But whether we're solving them through code or through whiteboarding or through writing technical documentation, you can't know what to solve unless you have that conversation with the people, like the stakeholders, who are the people who have the problem. If you're just receiving the business requirements from the analyst who's talked to them, then great. If you've got a great analyst, awesome. You can go and build your solution. But if you're the one designing the solution, you should be the one talking to the person who has the problem.
It's true. It's true. I think that's a great place to leave it, Aaron. Thank you so much for coming on the show, and thank you for your time. It's been brilliant. Great conversation. And we'll have to hit you up for season 2. Sure. I'd love to hear how it's progressing, how everything's going. And just appreciate everything that you're doing. And you're at the forefront of this. So really respect you. So thanks, Aaron.
Thank you very much.